welcome to my YouTube channel. In this video we are going to continue class 10th mathematics. This is real numbers unit test paper number 3. So now let us move for the first question of unit test paper number 3. The first question of unit test paper number 3 is, if the HCF of 65 and 117 is expressible in the form of 65m minus 117, then the value of m is dash. So we have to know what is the value of m. Before that one, first find the HCF of 65. 65 can be written as 13 5s and 117 can be written as 13 into 3 to the power of 2. 13 9s are 117. So what is the common to both? That is 13. So HCF is equal to 13. So 65m minus 117 is equal to 13. So ಇಲ್ಲಿ RHSL 13 ಇದೆ, LHSL 13 ಆಗಬೇಕು ಅಂದರೆ m ಪ್ಲೇಸ್ ಅಲ್ಲಿ 2 ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿ. 65 into 2 minus 117 which is equal to 13. So 65 2s are 130. 130 minus 117 which is equal to 13. So 13 is equal to 13. Therefore m is equal to 2. We have to get the value of m as 2. Therefore option B 2 is the right answer. For value of m we have to substitute 2. M is equal to 2. Now next, the least number that is divisible by first 5 even numbers is dash. The least number that is divisible by first 5 even numbers is dash ಅಂತ ಕೊಟ್ಟಿದ್ದೇನೆ. ಮೊದಲು 5 even number ಯಾವ್ಯಾವುದಪ್ಪ ಅಂದ್ರೆ 2 which is written as 2 into 1, 4 which is written as 2 square, then 6 which is written as 2 into 3, then 8 which is written as 2 to the power of 3, then 10 which can be written as 2 into 5. So LCM is equal to, so among 2 to the power of 3 is the greater, that is 2 to the power of 3 into 3 into 5. So 2 to the power of 3 is 8. Then 8 3s are become 24. 24 into 5. Or 5 3s are 15. 15 8s are will become 120. So LCM is equal to 120. Therefore the right option for this question is option A 120. Option A 120 is the right option. Next, let us move for question number 3. In question number 3, they have given how many prime factors are there in prime factorization of 5005. How many prime factors are there, that we have to find out now. So 5005 they have given. So 5005 you divide by 5. 1s are 0 0 1s. Now you divide by let us divide it by 7 is possible. 7 is 7. 7 1s are 7. 3 remainder 30. 7 4s are 28. 2 7 3s are 21. Then divide by 11. 11 1s are 3. 11 3s are. Now you divide by 13. 13 1s are 1 2 3 4. So how many prime factors are there? There are 4 prime factors. The right option is option B, that is 4. So like this we have to find out how many prime factors are there. Now let us move for second main, that is question number 4. So second main question number 4 is, if HCF of two numbers is 27 and their LCM is 162, if one of the number is 54, then find the other number. So HCF of two numbers they have given. So HCF of two numbers is H is equal to 27 and their LCM is given as 162. One of the number A is 54. Now we have to find out B, which is equal to question mark. So what is the relation? H into L is equal to product of HCF and LCM is equal to product of two numbers. So we want B. B is equal to H into L by A. So B is equal to H 160, that is 27 into L 162 divided by A 54. 27 ones are 27 twos are 2 ones are 2 eights are 2 ones are. Therefore, B is equal to 81. Therefore, another number is 81. So like this we have to find out. Next, let us move for question number 5. What is the LCM of smallest two-digit composite number, smallest two-digit composite number, and smallest prime number? So, what is the LCM of smallest two-digit number? So, smallest two-digit composite number. The smallest two-digit composite number na tagondre it will be 10. 10 is the smallest that is two digit composite number. So 10 can be written as 2 into 5. Then and the smallest prime number, the smallest prime number is 2. So 2 can be written as 2 into 1. So what is the LCM? So 2 into 5. 2 into 5 which is equal to 10. So 10 is the LCM of smallest two digit composite number and smallest prime number. So like this we have to find out the LCM. Now let us move for question number 6. Check whether 6 to the power of n can end with the digit 0 for any natural number n. So 6 to the power of n cannot end with 0 because 6 can be written as 2 into 3. So 2 into 3. So since 6 to the power of cannot end with 0 because 2 and 3 are the factors of 2 and 5. 2 and 5 are not the factors of 6. Since 2 and 5 is not a factor of 6 to the power of n, therefore it cannot end with 0. If it has to end with 0, cannot end with 0. If it has to end with 0, it should have the factor 2 and 5 both. 2 and 5 ಎರಡು ಇರಬೇಕು ಫ್ಯಾಕ್ಟರ್. ಒಂದಿದ್ದು 3, 2 ಇದ್ದು 5 ಇಲ್ಲ ಅಂದ್ರೆ ನೋ, 5 ಇದ್ದು 2 ಇಲ್ಲ ಅಂದ್ರೆ ಅದಕ್ಕೂ ಆಗೋದಿಲ್ಲ. So now let us move for third mean 7th question. So 6 to the power of n cannot end with 0 because 2 and 5 are not the factors of 6. The factors of 6 are 2 and 3. Since 2 and 5 is not a factor of 6 to the power of n, therefore it cannot end with 0. So this is the answer for 6th one. Now let us move for 7th one. Why 5 into 7 into 11 plus 7 is a composite number? So now 5 into 11, 5 into 7 into 11 plus 7. So 5, let us take 7 as common. 5 into 11 plus 1. So 7 into 5 11s are 55 plus 1. So 7 into 55 can be written as 55 plus 1 can be written as 56. So 7 into 56 can be written as 2 to the power of 3 into 7. Since it is a product of prime factors, 5 into 7 into 11 plus 7 is a composite number. So like this we have to find out the composite. We have to check whether it is a composite number or not. Next, let us move for 8th one. So prove that 2 root 3 is irrational. So we have to prove that 2 root 3 is irrational number. So let us assume that 2 root 3 is rational. If it is rational, then 2 root 3 is equal to p by q. So root 3 is equal to P by 2Q. So P by 2Q is rational. Therefore, root 3 is rational. This contradiction arisen because of our wrong assumption root 3 is not rational. Therefore, 2 root 3 is irrational. So like this we have to prove that 2 root 3 is irrational. Now let us move for question number 9. The ratio of two numbers is 3:4. LCM is 180. What is the first number? So they have given the ratio of two numbers. So let us solve this question now. So this is question number 9. So the ratio of two numbers is given as 3:4. So one number is 3x, another number is 4x. ಹಾಗಾದ್ರೆ ಇಲ್ಲಿ ಲಿಸ್ಟ್ ಮಾಡೋಣ. ಸೊ ಲಿಸ್ಟ್ ಮಾಡೋದಾದರೆ ಹೀಗೆ ಲಿಸ್ಟ್ ಮಾಡ್ತೀನಿ ನಾನು. ಸೊ ಎಚ್ ಸಿ ಎಫ್ ಇಲ್ಲೂ ಎಕ್ಸ್ ಇದೆ, ಇಲ್ಲೂ ಎಕ್ಸ್ ಇದೆ. ಎಕ್ಸ್ ಇಸ್ ದ ಎಚ್ ಸಿ ಎಫ್. Then A is equal to 3x, B is equal to 4x, LCM given as 180. Now let us find out the first number, that is A. So relation H into L is equal to A into B. That is HCF, that is X into LCM 180 is equal to A 3x into B 4x. So here 1x get cancelled. 3 4s are 12x is equal to 180. X is equal to 180 by 12. 12 1s are 6, 12 5s. So x is equal to 15. We want A. A is equal to 3x. The first number is A, which is equal to 3x. 3 into x is 15. Therefore, the first number is 15 3s are 45. If they ask a second number B, we can find out 4x. A is 3x, which is equal to 45. So like this, we have to find out the first number. Now let us move for the last question of this paper. That is prove that root 2 plus root 3 is an irrational number. So let us prove root 2 and root 2 plus root 3 is irrational. So let us prove that root 2 plus root 3 is irrational. So now let us assume that root 2 plus root 3 is rational. Let us assume that root 2 plus root 3 is rational. So root 2 plus root 3 is equal to P by Q. This is the first step. Next, root 3 is equal to P by Q. You shift plus root 2, it will become minus root 2. Then square on both sides, or you take the LCM now. Root 3 is equal to, or you take square on both sides. Root 3 whole square is equal to P by Q minus root 2 whole square. Square root get cancelled. 3 is equal to A minus B whole square. This is A and this is B. A square P square Q square plus B square root 2 whole square minus 2 into A means P by Q into B is root 2. So 3 is equal to P square by Q square plus this square and root get cancelled 2 minus 2 into root 2 root 2 P by Q. ಈಗ ಇದನ್ನ minus 2 root 2 P by Q ನ ಈ ಕಡೆ ಶಿಫ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಿ, plus 3 ಈ ಕಡೆ ತಮ್ಮನಿ. So 2 root 2 P by Q is equal to P square by q square plus 2 plus 3 become minus 3. So 2 root 2 p by q is equal to p square plus by q square. 2 minus 3 is minus 1. It is minus 1. So now 2 root 2 p by q is equal to denominator LCM, that is q square. So p square, q square ones are minus q square. So root 2 you keep only root 2 here, and 2p you bring to the denominator and q to the numerator. Root 2 is equal to p square minus q square by q square into q divided by 2 root 2. So q get cancelled. So root 2 is equal to p square minus q square divided by 2 ಇದೆ ಇಲ್ಲಿ. Oh sorry, so not 2, only 2p I have to bring here. 2p, sorry, ಈ 2p root 2 ಇಲ್ಲೇ ಇರುತ್ತೆ, 2p ಮಾತ್ರ ಕೆಳಗೆ ತರಬೇಕು. p square minus q square, ಇಲ್ಲಿ q ಉಳಿತು, ಇಲ್ಲಿ 2p ಉಳಿತು, it will become 2pq. So now p square minus q square divided by 2pq is in the form of p by q, therefore it is rational. Therefore root 2 is also rational. So idu rational andmele adu idike equal andmele that is also rational. This contradiction arisen because of our wrong assumption, root 2 is not rational. Therefore root 2 plus root 3 is irrational. So like this we have to prove it. So by this we have solved all the questions related to unit test paper number 3. In the next video we are going to solve unit test paper number 4. Till then, thank you very much. Still, those who are not subscribed my channel, please subscribe it. Those who already subscribed, please watch my videos, like my videos and share my videos, and don't forget to press the bell icon to get the notification for the next video. Once again, thank you very much.